Hey everybody, Robert Wolfert here. Welcome to this live stream. And this live stream is dedicated to one single tool I explained during my yesterday's live stream, where I had explained randomly chosen Linux command line tools. But I've got some questions for this one single tool, for the rsync tool. So I decided to do today a video only about this single tool, the rsync tool, with some preparations to show you how to leverage this tool for great backups over the network, over the internet. Yeah, you can use the rsync tool for doing backups over the network if you only have or you only need access to a remote system and you need a way to connect to this remote system via SSH. So typically, if you have access to a Linux system remotely, then you have access via SSH to this remote system. And if you have this, then you can use rsync for doing really easy backups. Yeah, so let me show you this in this video. Let me start by showing my screen. First, let's double check if the volume, the sound is okay. It looks great. Okay, so let's start. Doing great backups over the network with rsync. What I want to do today is I want to show you how to do backups, from a local system, the left system here. This is my demo system, and I want to do backups from this demo system over the network to a backup server or a backup system, a system where I want to store the backup. Yeah, and I want to do this over the internet, and I want to do this with the rsync tool, and I want to do this by leveraging an existing way to connect via SSH to the remote system. Yeah, local on the left system, I'm logged in as the user Robert, and I have my data within this directory, home Robert, within the home directory of the Robert user, and there I have a test data set, the directory project, and I want to leverage the right system. I have named the right system the backup server, the server backup, and I have a remote user there. I can log in as the user remote user, and I want to copy my data. I want to synchronize my data to the home directory of the remote user within the directory backup. Yeah, so this is the way I want to set up a backup here. Yeah, so let's take my consoles, my terminals here. So here I am on the left system. This is the left system, the system where I have the project directory, and this project directory contains some test data. And then I have on the right hand side the remote system. There I am logged in as the user remote user, and I have here a directory backup. I'm currently within this directory backup. Here I have this directory backup prepared, and I want to do backups, easy backups from this left side to this right side over the network. Yeah, so I have a really easy way to connect from the left side to the right side. I can connect via SSH. Yeah, so if I want to connect via SSH, I do an SSH remote user add, and then the backup system. I have included the name backup together with the IP address of the server into my etc host file, so that I don't have to type in the IP address here. I could type in the IP address here, yeah, but it's easier to read if I just write backup here. Yeah, so I can connect to the remote server. Let's try this out. it is the first time I connect there, so I have to say yes to the key, to the server key. I get presented, yes, tip yes, and I have a really simple password here, just for demo purposes. And now I'm connected as the remote user to this backup system, and I can leave the session. Yeah. So okay, so I have a really simple way to go from the left system to the right system, or connect from the left system to the right system via SSH. So now let's take the native way. Let's take the native way to do backups via SSH. And the native way, as I would call it, to do backups over SSH is the tool SCP. Let's make my picture a little smaller. Okay, so you can use SCP to copy a file, to copy a directory to a destination host via SSH. Yeah, and I can do this, for instance, in this way. I simply say SCP. SCP is the copy command with an S. The copy command with an S copies files via an SSH connection, the secure copy command. And I say I want to copy the directory project to a remote system, And when I want to copy to a remote system, I have to write the remote server, the remote IP or the remote username, the remote IP or the remote host name, followed by colon, followed by the path where I want to copy my data into. Yeah, so I want to copy my data to the backup server, and I want to copy the data there into the directory home remote user backup. Yeah, this is the directory here. Let's go into the backup directory. Let's call it pwd, print working directory. You see home remote user backup is the directory here, and into this directory I want to copy my project directory here. Now I'm here logged in as the user Robert. On the remote system I can log in as the user remote user, so I need to tell the SCP tool here to do the connection as a different user than the user I'm currently logged in as. So the way for doing this at the SCP command line is to write the remote user, then an @ and then the backup system, the remote system, the IP address, the host name, then a colon, and then the directory where you want to copy the data into. Yeah. If I call SCP this way, then I first need to log into a remote system via the password, and then SCP tells me, okay, project isn't a regular file, so I will not copy it. SCP by default only copies files. It behaves the same way as the single or the simple copy befehl does. If you want to copy directories recursively, then just add the command line switch -r for recursively. Now let's copy the project directory recursively to the remote system. Let's do this. And you see everything gets copied. We see the files within the output. Let's prove that we have really a backup here within the directory. Let's do an ls, and you see the backup directory, and within the backup directory you have the project directory, and within the project directory you have the files that were transferred to the remote system. So SCP called this way is a really simple way for doing backups but it's not the best way for doing backups. Yeah. First, if I do it this way, then only the data of the files will be copied over to the remote system, not the meta information about the files. Let's have a look. What I mean by that. ls-l. Let's have a look into the project directory, and let's have a look here on the remote system into the project directory, into the backup. And you'll see here that we have different timestamps. Yeah, we have different timestamps here. We have here the timestamp 933, and we have here the timestamp 1014. So the SCP tool doesn't copy the metadata of the files. The SCP command only copies the data with the names. Yeah. If you want to preserve the metadata, then you can call SCP with the additionally added command line switch P for preserving. The same command line switch you would use for the copy command, for a standalone local only copy command to preserve metadata, meta information, meta properties of the files during copy. The same goes here. If I copy my project directory this way and I have logged in with the password, then you see ls-l project, my backup now contains the correct timestamps. Yeah, let's have a look here. 933, 932, 1031, and the same here on this side. Yeah. Okay, so this is the way to do it natively via SSH tools, but it is not the best way for doing backups. Why this? Just because if I call the SCP command over and over again, then every time I copy the files, every file will be copied over to the remote destination. Every file. I don't have a large set of files here, yeah? But imagine you have a large set of files. You have a gigabyte or multiple gigabytes of data within thousands of files you want to copy from a source to a destination. Yeah? Then the SCP command will transfer every time you call it the whole bunch of files. Yeah? And the rsync tool does it in a better way. The rsync tool simply compares the local side with the remote side. Every file is compared. First, does the file exist on the remote side? Second, how are the metadata of the file? Do we need to update the timestamps and so on? And then the contents of the files are compared, and only if we see changes, only if rsync sees changes, then these changes will be transferred. Yeah. So let's demonstrate this. Let's remove the backup here. Let's remove the project directory rm-rf project. The directory is gone. And now let's call rsync here. Instead of SCP, let's call rsync. Rsync is a tool that is by default installed on the most Linux systems. If not, install it via the tools you know for your distribution, via yum or apt-get or via zipper, for instance, or just if you use SUSE. The rsync tool addresses the local directory and the remote destination the same way as SCP does. So we have a local directory project and we have a remote directory on a remote system and we need to log in as a different user as the user we are currently logged in as here. Yeah, so we can call rsync this way. And also for rsync, you need to add command line switches for doing copies recursively, for preserving timestamps, for preserving ownerships, and so on. And the rsync tool knows one single command line switch for doing these types of backup copies, the dash lowercase a command line switch for the archive mode. Yeah, let's start the archive mode for the rsync tool. And yeah, let's do this. But let's do this. Let's simply copy the files over. We don't see anything here. Yeah, just the password prompt and nothing more. But now the files are on the remote side. Yes, the files are on the remote side. And let's remove the files here, rm-rf. Let's remove everything here. Let's call rsync again. Let's call rsync now without the trailing slash here. I added the trailing slash here at this command line, and if you do this, if you add the trailing slash, then rsync will copy the content of the directory into the backup directory. And therefore, we have here the files directly within the backup directory itself. Yeah. But if you don't add a leading slash, then the directory itself will be copied over to the remote destination. Yeah. So this is a small difference only within the command line here, yeah, but a huge difference on the remote side. Yeah, you copy here the directory itself, or you copy the content of the directory. Yeah. Okay, so let's do this again. Let's copy now the directory itself, and let's add the command line switch V for the verbose mode, so that we see what rsync will transfer to the remote destination. Yeah. Okay. Let's call rsync. Let's log into the remote system, and we see the project directory will be created, will be transferred, then the readme, then the important txt file, and so on and so on. Rsync goes recursively through the project directory. Rsync has sent 1700 bytes here, and here on the system, on the backup system, you see you have the project directory as the backup, and within the project directory you have the files with the correct timestamp. Yeah, I just remember this timestamp here are the timestamps from my project directory. Yeah. Okay, great. rsync works now here just like the SCP tool. But if we call rsync again, then you see that rsync sends an incremental file list, and then rsync sends nothing because the destination looks exactly like our source. Yeah, so rsync don't need to transfer anything. rsync only transferred 20 or 226 bytes here. Yeah, so let's create a new file within the project directory. Let's create a new file, touch project test1, a new file. Let's call rsync again, and you see this file is transferred to the remote system. The metadata, the timestamp, for instance, of the project directory itself is transferred or was transferred to. And we have sent here 292 bytes. And let's prove that the test file is on the remote side perfectly. Yeah. Okay, so rsync only transfers files not already transferred. And rsync only transfers changed files. Yeah, so let's open the README file here. Project README. Let's open the README file. Only a placeholder. Let's append a second line. A second line of text. So now this file project README has changed. Yeah, let's call rsync again. And you see this file is transferred, and it is transferred project README, yeah, with this second line of text. Great. Yeah. Okay, so rsync only transfers changes. Yeah. So if you have 1000 files, 2000 files, and 1 or 2 files has changed during the last day, for instance, then rsync will only transfer these 2 files. Yeah. Let's have a look how rsync behaves with large files, with really large files. Let's create a test file. Let's use the dd command to create a test file. dd is a really simple command to read data from one source and write data to a destination. And you can see the dd command how much data, how many bytes, kilobytes, and so on should be transferred. Yeah. So let's call dd to read from the input file dev 0, and let's write the output into the project directory. The output file is project large file. And because dev 0 gives you more and more zeros the more you read in, we need to tell the dd command how many zeros should be transferred. And dd works with block-based. And dd works block-based, so you give 2 parameters. First, the block size, 1024K, for instance, 1 megabyte blocks, and we transfer 500 of these 1 megabyte blocks. Yeah, let's transfer this blocks into the file project large file. Let's have a look. Project. Now you see we have here a large file, exactly 500 megabytes in size. Yeah. Now let's call rsync. With this larger file. And perhaps this takes some time to transfer these 500 megabytes to a remote system. And if you transfer large amounts of data, then there is a nifty command line switch -- progress that shows you the progress of each file transferred. Yeah, and you see here again, have a look. This file is transferred to the remote destination. Yeah, and it takes 8 seconds left. Let's wait these seconds. Yeah. Okay, the file was transferred. Let's have a look. ls-l h project. We have the large file here. So now if we call rsync again, yeah, obviously rsync won't transfer any data now, but now let's append some data. Let's do some minor changes at the end of the large file. Let's append the string hello world to the end of the large file. The file is project and the large file is the name. So now the file is a little bit larger than 500 megabytes. We appended something at the end of the file. Now let's see what rsync does. And you see rsync transfers much faster the data to the remote system. Much faster. Why this? Let's scroll up a little bit. Here we had the speed, 32 megabytes per second. And here we have 178 megabytes per second. Why this fast? Because rsync doesn't transfer any data at all, but the end of the file. rsync just compares the data block-wise, on the local system and on the remote system. And from the point it sees changes. It compares from the start to the end. And from this point it sees changes or differences within the file. It transfers the remaining blocks, so that it goes really fast here. If you have a large file, a large log file, for instance, 100 megabytes, and tomorrow this file is 2 megabytes larger, then tomorrow there will be only transferred these 2 megabytes. Okay, this is really a great thing about rsync, that rsync transfers only changes it sees on files. And this works great if the changes are at the end of the file. So as they are at log files, for instance. Great command line switch for rsync you would use, or you should use, if you transfer large files. And if you transfer large files through an internet connection, through a WAN, wide area network, is the command line option BW limit, a bandwidth limit. You can limit the bandwidth the rsync tool uses. And this prevents rsync from eating up all your available bandwidth of your internet connection. You can do a BW, a bandwidth limit, and you can say, for instance, let's do a limit of 100 kilobytes per second. Let's remove the backup here, rm-rf project. Let's remove this. And now let's call rsync again. Let's call rsync again. Test 1, 2, 3. And you see it takes much more time to transfer the file. It takes much more time to transfer the file because we have a bandwidth limit here of 100 kilobytes per second. Perfectly. You see here the bandwidth used is 100 kilobytes per second. Let's terminate this. Control C. Let's call this again. Let's add a little bit more bandwidth here. Test 1, 2, 3. 1000 kilobytes per second. And you see it goes this way. 1000 kilobytes. And okay, and let's do this with 10 megabytes per second. Let's connect to the remote system, and you see you have 10 megabytes per second bandwidth used. Great. Okay, but now if you use a bandwidth limit, or if you transfer data, huge amount of data through a very thin connection, to a weak network connection, then chances are high that rsync will be terminated during the run. Let's say rsync needs 2 hours to transfer the files, and in between these 2 hours something happens. Yeah, so the rsync is terminated, and the next time you start rsync starts from the very beginning for transferring the files. Yeah, so we already had transferred 82%, but rsync starts again by 0 for transferring the file. Yeah, let's terminate this again, and let's add the last command line switch here for solving the problem we see here, and the problem is --partial. Partial means that rsync can resume interrupted transports. Yeah, if you copy files and you have copied half of the file and then rsync terminated, and then you start rsync again, then rsync can resume the transfer. Yeah. Okay, let's prove this. Let's try this out. Let's start rsync with --partial. Bandwidth limit 10 megabytes. Let's first remove everything here within the project directory. Yeah, so everything is empty again. And now let's log in. Let's start rsync test 1, 2, 3. Okay, and you see, yeah, it takes some time, and let's wait until 50%, for instance, or let's wait until 40%. Then I hit Ctrl+C to terminate the rsync command. Now, yeah, on the remote side, you see the project directory. You see within the project directory the large file, but the large file only has 222 megabytes in size. If you transfer again, yeah, or if you resume, yeah, if you call rsync again, then rsync resumes the transfer. Yeah. Okay, you see, we start directly with, we started directly with 40%, and then something went wrong with the BW limit. Yeah, but you see that it didn't take a lot of time to transfer the data. Yeah, let's try this again. Let's append some data. Hello world. Again to project large file. Let's call rsync this way, and you see it goes really fast here. Yeah, then we are at 100%, but rsync didn't transfer these 500 and something megabytes. Instead, rsync compared 500 and something megabytes on the remote side and on the local side, and it transferred only 107,000 bytes to the remote system, yeah, to transfer changes within the content of the file, to transfer changed metadata. Yeah. So this is a great way rsync works with weak internet connections or with huge amounts of data. Yeah. You can use the progress to see something. You can use the switch BW bandwidth limit to limit the bandwidth that can be used by the rsync tool. And you can use the command line switch partial to allow rsync to resume transfers of files. Yeah, --partial. Some minor things to mention here. First, the rsync tool doesn't delete files on the remote destination. Yeah, I have here on my local side file test. Yeah, let's remove this test file here, rm project test1, and now the file isn't there anymore. Let's call rsync. Let's go to the other side and let's have a look into the project directory, and you see the test1 file is still there. That's because by default rsync doesn't delete anything on the remote side. Yeah. If you want to, then you need to use a command line switch. Let's append a command line switch here at the end of the command line, --delete. --delete says to rsync, please delete everything that is on the remote side that is not on the local side anymore. Yeah, --delete. If you're unsure if everything is correct, yeah, then let's do a dry run first. A dry run means that rsync will tell you what it does or what it would do if you run rsync without this dry run command line switch. Yeah. So if I call rsync this way, I have appended --delete and I have appended -n for the dry run. Yeah. I connect to the remote side. Then rsync says I would delete the file project test1. And great, this is what I wanted it to do. Yeah, it was only a dry run. Yeah, so within the project directory, the test1 file is still there. Let's remove the dry run command line switch, --delete, and now you see here the test1 file is gone. Yeah. Okay, so this is a typical command line you will use for the rsync tool. Yeah, --progress. Perhaps if you watch the rsync transferring the data, the -v for verbose. Perhaps if you are watching rsync, but what you need is the -a for the archive mode. What you need is perhaps the bandwidth limit. But what you should use is the partial command line switch, and what you should use, or what you need to use if you really want to synchronize from a local site to a destination site. Yeah, so that deleted files will be deleted on the destination site. You have to add the --delete command line switch. Okay, last thing we need to do here is we need to get rid of this password prompt, because if we wanna automate this, yeah, then we don't have a way to enter a password here. So what we need to do is we need to implement a key-based authentication for SSH. Yeah, and I do it here the fast way, just to show you that it is possible to do a key-based authentication for SSH. I have done some time ago a video about this, and if I remember at the end of the session, I will put a link to this video into the comments of this video. Yeah. Okay, I want to get rid of this password prompt. I want to create an SSH key pair for authentication. SSH key gain is the tool for this. Yeah, just call the tool SSH key gain. Let the tool choose the destination for the keys by itself. Yeah, just to be sure that the SSH command later on or the rsync tool later on, the SSH libraries later on, yeah, they find the key without further or adding another command line switch. Yeah, just use the default here. We want to automate something, so we don't want a passphrase. So I hit enter here for creating a key without a passphrase. Yeah, but creating keys without a passphrase, do this please only for keys you use if you connect to a remote system without huge rights, huge permissions. Yeah, because every time, or if someone can steal this key, he can connect to every system the public key is copied to. Yeah, so only for these automation purposes here, leave the passphrase empty. So now I have created with SSH key gain my key pair, my SSH key pair. SSH key pair is here within my home directory, within the .ssh directory, ID RSA and ID RSA.pub. And this public key here now has to be copied over to the remote system. And there is a really easy tool that does this for us, ssh-copy-id. And I want to copy my ID, my identity, and this public key here, I want to copy this identity to the remote system. The remote system is named backup, and I have to log in as the user remote user at backup. Yeah, I need to log in via the password, and now the key is stored on the remote system for the remote user within its home directory, there within the SSH directory, and there within the file authorized keys. This is the public key. This is the public key that comes directly from this local system, ID rsr.pub. This is the public key. Yeah, this is exactly the key that was transferred to the remote destination. And now I can use rsync without entering a password for the remote side. Yeah, great. Works as expected. Yeah, I can call rsync, hit enter, rsync works. Great. Yeah, and now I can implement this command line as a cron job, for instance, within etc cron tab. Yeah, if you take etc cron tab, let's take this here, let's append into etc cron tab. Let's say you want to do every day at 4:20, at 20 past 4 on every day, you want to do this command line here. You could do it this way. Yeah, but for now, let's leave this. I don't want to do a cron job here. Yeah, but this is the way rsync can help you to do really easy backups. Yeah, keep this in mind. rsync only transfers differences between directories. rsync can be told to resume transfers that were interrupted, and rsync can be used with bandwidth limits, yeah, to avoid eating up the whole bandwidth you have with your internet connection, for instance. So I hope that makes sense for you. If something isn't crystal clear, give me a comment, and I will answer the questions later on. But for now, let's end the stream. Have a nice Tuesday.